What if we run out of data? As we know, LLMs are trained on data from the internet, also private repositories, things of that nature. But certainly at some point, we're going to end up in a state where the data it's training on is no longer human. There's an article here discussing what will happen. Now, this article particularly focuses on text, not purely code, which is worth mentioning because there is a difference. And so here it says, in this paper, we examine the challenges and opportunities that lie ahead of scaling machine learning systems, particularly in light of the finite nature of public human text data. Right at the start, we pretty much could assume majority of the data on the internet was written by a human. But as we've gone over time, we're starting to see, hey, 2026, now we don't know, right? It might be 95% human. It might even be less than this. If it's an email, they're going to parse it through some LLM first as a second look. And just by doing this, depending how they handle the results, some people, they just feed it straight into the output. Non-human data being part of our training now becomes synthetic data in a way because it's been already doctored by the LLM. Our conclusions are thus twofold. On one hand, we expect that the current paradigm based on public human text data will not be able to continue a decade from now. On the other hand, it is likely that alternative sources of data will likely be adopted before then, allowing ML systems to continue scaling. Right? So this argues that yes, we will be at the end of the human data, but it may not be as big of a problem as we're worried about. This article here from Forbes talks about how we are running out of data as well, and it particularly harps on synthetic data here, where it says employing synthetic data may not fully resolve data shortages and even be a drag on AI performance, they add. And they kind of highlight the benefits of having a mixture, right? Human data plus synthetic data. But in context of coding though, and one key point here is that simply adding more data does not necessarily lead to performance gain. There's still no definitive evidence that synthetic data can fully offset real data depletion in pre-training context. Now, it had me at the first sentence, right? Simply adding more data does not necessarily lead to performance gain. This part is agreeable. I would say the second part has very little bearing. And so let's say the day has come. We've ran out of human data. All we have now is synthetic. We're all familiar with the gap between Fable and Opus. Really, this felt like a meaningful increase in performance, and it happened over a very short period of time. And Fable 5, if we go to the system card for Fable 5, they even call out, right, Mythos and Fable 5 were trained on a proprietary mix of publicly available information from the internet, public and private data sets, and synthetic data generated by other models. And so if we look at it kind of from an outer lens, we're effectively sending data that, they got from the internet, as mentioned, websites, repos, etc. But it's not just raw straight into the training process. Like if we assume this is a black box of training, right? So think about, iterations, epochs, pass and fail, all this logic that goes into training. Just imagine that's in this box here, right? Coding LLMs are very much pattern matching. There are some pass-fail incorporation into it. And so they will introduce kind of algorithms that haven't been solved yet and have the LM solve it, and that gets fed in. For the most part, as far as GitHub repos go, and it prioritizes it based on things like reputation. There's a lot of metrics that go into how they weight each of these repos. This is just me giving an example. The React source code is going to be weighted better probably than some calculator app that it finds. And so there is some, fine-tuning and knob work that goes into this. So it's not exactly raw. And a key part here is that throughout the training process, we use several data cleaning and filtering methods, including deduplication and classification. There's a lot more that goes into making a model good. It's not just data. And so the success of Fable really wasn't about adding more data. Most of the success of that model is because they fine-tuned the data that they already had. And so this article here really shows the impact that synthetic data has on the output. And here we can see that synthetic data was actually used to reduce the gap of DeepSeek and more expensive models. The conclusion of the article was that fine-tuning via the synthetic subsets improved their performance in cases like LeetCode and areas where smaller models would struggle. It was able to achieve by incorporating synthetic data. Here we have a post from Anthropic kind of showing the flow of using synthetic data. Notably, we find that our synthetic documents are comparable to and sometimes even better than real pre-training documents at inserting beliefs about true events after the knowledge cutoff. Right? So there's evidence here that synthetic data, if done right, can actually be better than human written data, unfortunately, right? And so while I agree that simply adding more data does not necessarily lead to performance gain, I think this part is a little bit misled. I think there's definitely very good truths that synthetic data is improving our models. The data issue of, hey, what if we run out of human data? I think that's not really our concern here. I think the real concern is on other things. We've all heard about how important harnesses are, right? If you use the same model in Cursor versus something like Copilot or some other harness, it's going to perform a lot different. Data cleanup, right? You could have all these websites and repos, but the amount of effort that you put into labeling this data has an impact on the output. And so you might think to yourself, right, are we at a point where we've capped out? Will we ever see an Opus 4.7 to Fable 5 transition? While I do think we probably won't see this big of a jump in a short period of time, I think it'll dwindle a bit. There are so many areas where we can improve. As we discussed before, there's a lot that goes into data preparation, cleaning up data, deduplication, synthetic data, as we talked about, right? You could be coming up with algorithms, right? Because that's one strategy people have, is that they feed in a problem to the LM and it'll work on it and work on it and work on it. And then eventually it'll solve it, and out comes a sort of training report where it'll list out like, hey, here is what we did. Obviously it's not, this is human speak, but there'll be like a bunch of information showing what it did to get to the end result, and then that goes into the data. And so really, in a way, we're slowly or quickly approaching a state where we are in a janitorial position. We've already gotten all the data from our humans, and now we're cleaning it up, fine-tuning it every here and there. This article here from Anthropic, where it talks about AI building upon itself. History, humans drove every step in its development cycle, but at Anthropic, we are delegating a growing share of AI development to AI systems themselves, which is speeding up our work. Right? They already have this today where it's already doing a full synthetic loop. The entire loop is synthetic, where it's doing the part of waiting and preparing. Building a frontier model takes two broad categories of work. There's engineering, which is writing the code, standing up the infrastructure, and overseeing the model training. And there's the research, which decides which experiments to run, interpreting what comes back, and figuring out which ideas to try next. Anthropic and all these labs, they're constantly thinking about how can we improve what we have? The data that we already have that's human, how can we improve it? How can we generate new effective data? What kind of problems can we feed the LM and have it go and solve, so that way we can feed it back in and have a good bit of training data. It goes on to say, across both engineering and research, the picture is consistent. In engineering, Claude can be handed an underspecified problem and figure out how to solve it. Humans supply the goal, but they no longer need to supply the method. This right here is why it's not a big deal. If we run out of human data, we can just continue on, because we're going to give the LM its own methods. We're going to give it a problem to solve, and it's going to figure it out on its own. And so I think that we know at the end of the day, human data is not going to stop us. It's going to keep us going. We're going to keep going past it. I do think we're not going to see as big of a jump as we go on. I do think we're going to reach a state someday where we have model equilibrium. And by that, I mean all of the labs have a very effective model. And at that point, your question is which one do you use? They're all pretty damn similar, because today, right, you do have some differences. There's certain reasons to use each of these models. But as time goes on, that difference is going to lessen. While an Anthropic Fable model might feel +5 in some cases, and it might be something like this, as time goes on, these are going to become closer and closer. You're going to end up in a state where it's like, dude, they are effectively the same effectiveness at every situation, because we're reaching that kind of bottleneck. And I don't think we're here anytime soon, but I do think we're going to see the gap between these models reduce over time. I think we're already seeing that. Right? There was a point in time where Anthropic's coding models were massively ahead of everybody else. So now there's a much lesser gap between OpenAI and Anthropic. And as we're seeing, right, even Grok is starting to catch up a little bit here and there. Same with Meta. And so this gap is lessening. And I think what's going to happen is you're going to end up in a case where it's not so much the model that decides the impact, but rather the engineer. Kind of alluded to earlier, a big importance here is the harness. And then on top of that, it is the prompt. And so as far as the harness goes, if you're familiar with Pi, which is a terminal app, Pi's harness is as bare minimum as you can possibly get for many of the kind of externally accessible terminal apps. Whereas other applications such as Claude Code or Cursor, these have a very dense harness, right? These are harnesses that have been developed over years and years, which in some cases is beneficial, right? We've seen Cursor's harness is actually really good and outperforms in a lot of ways. But you really, these harnesses that you see in like something like Cursor, these are general use harnesses. They're really good in most cases, but they'll never beat a harness that was fine-tuned specifically. And so that's why I believe an app like I is actually going to have an impact on how good of an engineer you can become, right? When you're given a bare bones harness, it's up to you to fine tune it to actually be effective for your use case. And so I think we're going to see harness engineering be ever important as these models get closer and closer to each other. Harness engineering is going to be what decides how you perform. And in a lot of cases, I think we're going to have very fine-tuned harnesses that work for very specific scenarios, right? You might have a harness that's fine-tuned for game development. You might even have a harness that's fine-tuned for your specific setup, right? You might have internal specific workflows that are fine-tuned to work well with a certain harness. This is the level that I expect it to get to. And then of course you have the prompt, which also takes effort. We can assume prompts are a massive impact. At one point in time, you could send an awful prompt to an Anthropic model and it would still manage to outperform any of the other three. Nowadays, even today, right? It depends on which models you use. If you use an OpenAI model and you send a bad prompt, you're getting a bad output, let me tell you. But if you send a bad prompt to Anthropic, it'll still figure it out, right? There's a lot more listening that goes on with OpenAI, but the main point here is that the prompt is impacting more and more, right? It's no longer the case that, oh, if you want something to work, you have to use this model. Really, you could probably get XAI models and meta models even perform at this upper echelon as long as you really put a lot of time and effort into the prompt and the harness, both of these. And so we will really end up in a case where the bottleneck is the engineer, not the data. And part of this is bad news, right? Because we're realizing, hey, this is just going to keep going. These models are going to keep getting better. I love that. Like, to me, I love that. I don't think we'll ever see as big of a jump as we saw with Opus to Fable. I think that's past us now. But I definitely don't think us running out of data is going to be the issue here. I think it's going to come down to the harness and it's going to come down to your prompt. And both of these are very unexplored places, mind you. We're seeing improvements day in and day in on harnesses, and prompt engineering is still something that takes skill and refinement. Things are going to develop over time. A lot of people are going to learn tricks and ways to improve on this area. And I don't think what holds us back here is going to be the data. We have synthetic data that is obviously proving to be very effective. And we're even seeing cases where the model is training itself, right? This one here, self-adapting language models. This, shows how really the model can, and as we kind of discussed in the Anthropic article, it's really doing it all of it on its own, right? You could just have it run. Obviously, it's probably pretty expensive, but you could effectively just have the model run and do its own loop of training. And then you come back maybe a few days later and it comes out, hey, it worked pretty well, right? You could have this go and go and go.